We are slowly getting closer to a complete rig, and in its current state we could pass this on to an animator, and they can begin to bring life to this creature. However, before we do, there are a few more steps we need to take. The first is optional. What we are going to do is add in some extra functionality by making the character's limbs and torso more flexible with some squash and stretch. The next step, which is covered in the next video, is to make sure everything is locked down and secure, and this step is very important. We will cover this later though. Really quick question for you now. How would you like to help support the future of this channel and keep these videos free? Well, there are a few options. One would be to simply treat me to a coffee at my coffee page as a quick and easy thank you. You could also grab something from the antCGi store or one of my other online stores like CubeBrush and Gumroad. This is where you will also find the course files that go with this course, so you can download them and follow along. However, for as little as 99p a month, you could join the antCGi club. There are a few ways you can join. You could head over to my Patreon or Coffee pages, or alternatively simply hit that join button below this video. In short, the more support I get, the more time I can dedicate to creating more high quality content just for you. To get more information on how you can help, follow the link on the screen or in the description below. Okay, now that's out of the way, let's get on with the video. Okay, so first let's look at the torso. If we pull the shoulder control, which is the IK spine control, you see that the torso stays in place, which looks odd. So ideally we want the spine to stretch so it moves with the control. Okay, let's show the rig systems. And we need to find the curve we used when setting up the IK spine. Now open the node editor and bring the curve in. Usually we hide the shape nodes, but this time we need them. This is the one we need, so let's remove these instead and open this. And now we need a new node, so press Tab and create a curve info node. Call it Spine Curve Info. Next, connect the curve's world space 0 attribute to the curve info node's input curve attribute. So what this node does is tell us a lot of information about the curve, which you can see in the attribute editor. The one we are interested in is the arc length, which tells us the length of the curve. We can use this to check when the spine is stretching, and then use that information to also stretch the joints so they follow. So first we need a new multiply divide node. Let's open this and rename it to Spine Scale Factor. Connect arc length to input 1x. So here we have the curve length. We are going to use this node to compare its stretched length against its base length. To do this, copy the value down to input 2x. Okay, let's look at it in the attribute editor. Change the operation to divide. This will divide the first value by the second and give us a result. The result will be 1 when the values are equal, and then this will adjust as the curve stretches. So what we can do then is use that value to then adjust the scale of the joints, because the joint's default value is 1. Okay, let's make some room. Now create a blend colors node. This node is traditionally used with shaders, meaning you can blend between the color 1 values and the color 2 values here. We can use it to blend between two values, which will give the animator the ability to turn the stretchiness on and off. Call it Spine Stretch Blend and copy it. So this one is going to work in a similar way, but we will use this to automatically turn off the stretchiness when using the FK controls. or alternatively, enable it when switching to IK. If the stretchiness remains on when using FK, it will still be referencing the IK spine, so we need to disable it. Let's add IK to the name here so we can differentiate between them. OK, now set all the attributes on each to 1, because when the stretchiness is disabled, we need the scale values to be set to 1, again, which is the default value on the scale attributes. So we have those set up. Next, let's connect these to some of the key attributes we added. We added these attributes earlier, so we could change the spine so it only stretches, only squashes, or does both. The stretchiness attribute here will be what we use to control the blend colors node here. So bring in the cog control, and simply connect stretchiness to the spine stretch blend node's blender attribute. We now need a condition node. So let's open that and rename this to spine stretch condition. Let's move some of these. Now connect the scale factor's output X attribute to the condition node's first term attribute. This is so we can use a condition node to check when the curve is stretching. So, as we have before in this series, we can compare the first and second terms here and determine what needs doing. Now connect output R from the stretch blend node to the color if true R attribute. So when the condition is true, it will output the stretch value. We can use the operation attribute to adjust how the torso scales. But what we need are the not equal, greater or equal, and less or equal options, which are equivalent to numbers 1, 3, and 5 in the menu. We need these attributes on the cog control to adjust the condition node's operation attributes. The problem is, if we connect them directly, the stretch type attributes options will output 0, 1, and 2, not 1, 3, and 5. So these won't tie up to the correct operations. So what we need to do is insert some kind of offset, which will change those values and push them onto the correct ones. Create a plus-minus average node and open it. Rename it to Spine Stretch Control PMA. Connect stretch type to input 1D0 and input 1D1, and also input 1D2. So what this will do is add up all these values, so it will give us an offset. If we change stretch type to stretch, you see these values have now changed to 1, so the output would be 3. We need the first option to be just 1 though, not 0. So let's break the connection on input 1D0, which means this will always be set to 1. So when the attribute is set to both, this will output 1 now, not 0. Okay, let's connect this to the condition node so we can check it, and you can see it in action. Now connect output 1D to the condition node's operation attribute. So you see, the operation is now set to greater or equal, meaning the spine will only stretch when the curve is longer than it should be. If we set stretch type to both, the output is now 1 from the plus-minus average node. So the operation is set to not equal, meaning the spine will stretch and squash. Finally, let's swap this to squash. And the operation is now less or equal, meaning the spine will only squash when the curve is shorter than it should be. Okay, now let's connect the condition node to our other blend colors node so we can check if we are working in IK or FK. So take out color R and connect it to color 2R. And we also need to control this with the IK-FK switch attribute too. So connect that from the cog control to the blender attribute. Okay, anything else? Ah yes, we need the scale factor value to also be connected to the stretch blend node, otherwise we won't know what values we are using. Connect it to color 1R. So this will blend between the amount the joints need to scale, here, or a static value of 1 if the stretchiness is disabled. Okay, let's move the control up a little so we can see the spine update. And now we need to connect this network to the joints. Bring the main IK joints into the node editor. So these are spine 1, 2 and 3. We don't connect the pelvis or the neck because this will then affect the pelvis and head, whereas we want this restricted to just the spine. Now simply connect output R to each joint's scale Y attribute. We use scale Y because that is the axis which is pointing down each joint. Okay, that's done. Let's check the attributes. So we need stretchiness to be enabled and stretch type to be both. Okay, there, the spine snapped into position. I can move the shoulder control now and the torso stretches to move with it. We can also adjust the stretchiness to turn it off if needed. Let's check the attributes. Okay, they aren't working yet. Maybe we missed something. Oh yes, on the condition node we need the second term to be set to 1. If the first term is above 1, the spine is stretching. If it's below 1, then it's squashing. So with it being set to 0, it wasn't triggering correctly. Okay, that's only squashing now. Now it's working both ways, so both squashing and stretching. Okay, good. Now even though this is affecting the IK joints, we also want the main bind joints to scale too. This is so the geometry is distributed more evenly. So bring in the main spine joints, so just 1, 2 and 3. Let's move this so you can see it as it updates. And again, connect output R to each joint scale Y attribute. So you see the geometry is much smoother here now. There we go, much better. A stretching spine. And we can blend to FK, and the spine moves back and disables the stretchiness too. What we have now is a torso which stretches, which is good, but it doesn't maintain its volume. What I mean by this is it doesn't get thinner the more it stretches, or thicker when it squashes. Let's add that functionality in next. And it's pretty straightforward now we have the main stretching network set up. All we need is another multiply divide node. Call this spine volume multi. This time we need the operation to be set to power. What this will do is take the input 1x value and then multiply it by itself the number of times in input 2x. So if input 1x was 2 and input 2x was 2, it would be 2 times 2. Set input 2x to -1 because we want the scale value to get smaller the more the torso stretches. Now connect out color R from the condition node to input 1x. Remember, this is the main scale value being output, plus it's being controlled by the condition node. Let's reuse the IK blend colors node now. So we can again control the influence depending on whether the animator is using the IK or FK spine. Connect output X from the volume multiply divide node to color 2G. And now we connect this to the other scale attributes on the joints. Actually, let's use a connection editor. So load the blend colors node into the left side and the bind joints into the right. We only need these because they influence the model. So we need output G, and this time connect to scale X and scale Y on each joint. You can see they are now connected up here. Now as we pull the shoulder control, the torso changes shape as it stretches and when it squashes. It's also ignored when switching to FK. So the spine is done. Let's move on and set up the arm. And this is very similar to the spine. We just have to take a slightly different approach. With the spine, we were able to check when it was stretching by using the curve, but obviously we can't do that with the arm. So we need to find a different way of getting its length and then finding out when it should be stretching. Let's build some of the basic nodes first. So jump back into the node editor. First, we need a new multiply divide node, and this will act as a scale factor node. So rename it to arm left scale factor. And open it. Let's have a quick look back at the spine's network. We used the curve info node to give us the length of the curve, but we could also use this to check when it was stretching and convert that into a usable value too, with the scale factor node here. Let's go back and change the operation to divide. So we need to find the arm's current length, but we already have everything we need to find this. Let's find the arm joints. If I select the lower arm joint here, we see the distance this is from the upper arm joint over here in the attribute editor. This is because we corrected the orientations, so the y-axis is pointing down to the lower arm. So make a note of this value. Now select the hand joint. And again, we can see the distance this is from the lower arm joint here. So remember this value too. All we need to do is add those together, like this, and we get the arm length. Let's bring back the node editor and add that into the scale factor node in both input 1x and input 2x. So that's stage 1. Now we need to check for when the arm is stretching, so when the control here is moving away from the arm. What we can do is get the distance from the arm IK control to the root control, and when that goes above the arm's length, we know it should be stretching. Let's bring the root control into the node editor. Now we can't use the IK control directly because it will cause some evaluation issues, but we can use a dummy node instead. Let's just use a locator. We can duplicate this one, the arm left IK swap position one we created earlier in the workshop, and simply match it to the hand joint's position and orientation. Let's rename this to end pos, because it will indicate the arm's end position. So we have our two nodes now that will mark the start and the end of the arm. Create a new node now, this time a distance between node. This will do exactly as the name suggests, and tell us the distance between 2 points. Call this arm left stretch distance. Connect world matrix 0 from the root control to in matrix 1 and world matrix 0 from the end position locator to in matrix 2. The distance attribute here will output the distance between these two and keep it updated, so we will see when the arm should be stretching. Connect that to input 1x on the scale factor multiply divide node. So here we have the distance value now. if I move the arm control away, you see it's increased. OK, undo that. So this is set up and will output a value of 1 when both values are equal. Now we need the two blend colour nodes. Let's just duplicate the ones we created for the spine. And rename them to arm left instead. So the rest of the setup is exactly the same as the spine. Let's connect the main attributes to the blender attributes next. Bring the arm IK control in and connect stretchiness to the stretch blend node's blender attribute. Now connect IK-FK switch to the stretch IK blend node's blender attribute. So there we have our two main controls. Let's make this a bit bigger. We now need the main scale amount. So connect output X from the scale factor node to color 1R on the stretch blend node. So that will blend between the scale value here and 1. Let's work on those extra stretch type attributes now, so we can control whether we want the arm to stretch, squash, or do both. Again, let's just copy the nodes we created for the spine to speed things up. We need the plus minus average node and the condition node. Here we go, and rename them. Just as before, connect stretch type to input 1D1 and input 1D2. Remember to leave input 1D0 set to 1. Let's move this over here. Now connect output 1D to the condition node's operation attribute. This will control the operation, changing it for us. OK, now we need the scale adding to the condition node. So the scale factor's output X value goes into first term. And then we want the stretch blend's output R attribute to go into color if true R. So the joints will stretch when the condition node tells them to. Now we feed the results of this through the stretch IK blend node to again check if we are working in IK or FK before it passes this to the joints. So connect out color R to color 2R. Now we connect this to the joints. So let's find the arm IK joints. We just need the upper and lower arm joints. And now connect output R to each joint's scale Y attribute. Let's test that. The arm stretches. If we set stretch type to both, it squashes and stretches. And if we set it to squash, it doesn't stretch, but it does squash. Stretchiness works. And so does the IK-FK blending. OK, good. So now we need to include the bind joints too, so the scale affects the geometry. So let's find those and bring them in. And again, connect output R to each joint's scale Y attribute. We could use the connection editor for a change. OK, there we go. The arm can now move and stretch. Okay, so just like with the torso, let's also add in some volume preservation. And this is exactly the same as we did with the spine. Bring back the node editor. If we look at the spine, we have the volume multiply divide node here. So let's just copy that. And open it. And move all these over. And rename it. Because we copied it, this node is already set up for us, so all we need to do is add the connections. So, connect outColorR from the stretch condition node to the volume node's input1x attribute. Here we go. And output x goes to color2g. Let's open the connection editor so we can connect this to the joints. So output G here, and load the bind joints into the right side, and connect output G to scale X and Z on each. Now the arm gets thinner the longer it is. Again, we have some weights we need to adjust here, but we can come back to those later. That's the torso and arm done. With the leg, you can take the same approach as you did with the arm. Just use the value in each joint's translate y attribute to get the initial leg length, but make sure you add in that extra joint. Now I'm not going to go through the process of building that all again, because like I said, it's very similar to the arm. So what I'm going to do now is I will update that, and I will be back in a second. Okay. All the limbs are now set up with full squash and stretch abilities. The spine is working too. There are a few things I need to point out before we move on. If you open the node editor on this file, you will see that I've added these extra tabs, so you can see each section's network and are able to pick through it. Let's look at the arm. So with this, make sure you also connect the twist joints too, so they scale as the arm stretches. With the upper arm joints, don't add volume preservation into these, or it will look too thin. You can, however, add it into the twist joints. With the legs, also include the twist joints. And also remember to connect the driver joints too, or the legs won't stretch correctly. Again, feel free to look at this file and these tabs if you are at all unsure. Okay, so that's squash and stretch covered. We have one more video to go now before this rig can be passed to an animator. So in the next section, we will look at making the whole rig scalable and also locking it down so it can't be broken. Okay, that's another video over. Thanks for watching right to the end, and make sure you also check out some of the other free videos and courses that I have available. You can find links to all these on the screen now and in the description below. Remember, to help support future content and keep these videos free, visit the antCGi store or join the antCGi club. Alternatively, if you would just like to show your appreciation for these videos, why not treat me to a coffee at my coffee page? Again, the link is on the screen now and in the description below. Thanks again for watching. This is antCGi signing off, and I will see you on the next one.